Hey, hi, folks. Hey, hi, folks. Today in this particular video, we will be going to discuss about. Hi, folks. So, in this particular video, we'll be going to discuss about another particular series, as I promised, uh, a day 2 interview, data science interview uh, series, day 2. So, in this particular video, we will be going to discuss about D2, what are the interview questions they can ask, and how you can present to the interviewer. So these are the things you have to look into it. So welcome to my channel, folks. Welcome to Aakash on the technical channel. So in this particular video, we'll be going to understand how you have to answer the particular question whenever the question is encountered to you. All right. So, for number one, like what is a logistic regression? First thing you have to understand logistic and regression. Okay, logistic regression, logistic regression. So it contains two values. Okay, it technically like technique. It is a technique. Logistic regression is a technique. It involves the dependent variable which can be represented in the binary 0 or 1. Okay, 0 or 1. 0 is false and 1 is true. Okay, or yes or no values. Okay, which means that the outcome could only be in either one form or two. Okay, one form of two. Okay, for example, so when we need to find a probability of a success or failure for a particular event, so we'll tell it as happy or like uh, true or false, right? So this is a particular consideration you can take it for any particular logistic regression model. Okay, you pass the parameter. Okay, let's suppose there are three parameters. You needed to find a particular classification where you are happy or sad. Okay, so weights are theta naught, theta 1, theta 2. Outputs are like happy or sad. Okay, this logistic regression is like when the dependent variable, which particular target, whenever the target variable is a classification, how will you will get to know that a particular problem is classification? You will be going to understand like classification categories like 0, 1, yes, no, success, failure, fail, pass. So these are the comes into the categories of uh, classifications. Okay, let's get dive into it. So output will be the model for this particular model. Output will be equal to 0 or 1, right? So z Z is equal to wx plus b or mx plus c, you can call it as. Okay, here whatever the prediction you will be going to present, it will be a sigmoid curve. Okay, sigmoid curve. So h theta of x, which is equal to log of probability of particular x divided by 1 minus p of x. Okay, so for this particular h theta of x, we will be going to compute with the sigmoid, which is equal to 1 over 1 plus e power of minus t. Okay, don't think too much, folks. Try to explain them what is this particularly. Okay, they will be not gonna, they need to understand that you know the certain things. Okay, so if z goes infinity, okay, this z is nothing but sigmoid. Okay, when z goes infinity, y predicted will becomes 1. Okay, if z goes to negative infinity, y predicted will become 0. Okay, see, understand like this. Y predicted will become 0 like this. Okay, if it is like, if it is an infinity, then it will become 0, right? The output from hypothesis is estimated probability. This is used to infer how confident predicted value be actual value when a given input x. Okay, so try to understand like that basically. So cost of h theta of x comma y, which is equal to minus y log of h theta of x minus 1 minus y log of 1 minus h theta of x. So what does that cost function it is? Cost function is nothing but why we compute basically to what's a particular error in your particular model is about. Okay, so let's say if you compute as y equal to 1, okay, wherever the y is there you will be computing y equal to 1, so you will be getting the term 1 minus 5. Okay, so term will become 0, so therefore minus log of h theta of x will become, right? So minus log of h theta of x will become, so when it is 0, so it will be minus log of 1 minus h theta of x. So cos function of h theta of x comma y actual. So predicted comma actual you are going to term. When if y equal to 1, then this equation will be equal to minus log of h theta of x. If it is 0, then it will be minus log of 1 minus h theta of x. Okay, so it is a implementation is for the binary classification, binary logistic regression. For the data with more than two classes, softmax regularization has to be used. Okay, so try to understand like this. I know these things will be going above the head. Okay, so let me know like if you want a depth explanation about it. If you want, then let me know about it. Why? Because these are the important interview question I'm going to discuss. If you have any doubt related to particular this particular thing, yeah, Akash, how is this particular thing going to implement? Just comment down below, folks. Okay. So now, what's the difference between the logistic and the linear regression? You have to give me this give me this question answer, folks, and comment down. Okay, linear and logistic are most form of a regression which are commonly used. The essential difference is that the two is that logistic regression is used when dependent variable is binary. In contrast, linear regression is used when dependent variable is continuous. And the nature of regression line is linear. Okay, okay. So this is a particular thing. Like what the key differences between the linear and logistic. So linear regression data using against the continuous numerical value as against the logistic regression models data and the binary values. Okay, linear regression requires to establish the linear relationship between among dependent and independent variables, where it is not necessary for logistic regression, right? Okay, in linear regression, what happens is that independent variable can be correlated with each other. Independent variable can be correlated with each other. On contrary, in the logistic regression, the variable must not be correlated to each other, right? So this is a particular key differences you have to talk about it. Whenever they talk about like what is the differences between the logistic and linear regression, why it is the meaning of a regression itself. Okay, so you have to talk about like this basically. Okay, so like it is a continuous where the variable is continuous in logistic where it is a categorical data we can take it, okay, which contains the binary values. There is no correlation between them, between the independent and independent variables. So why we can't do the classification problem? Why we can't do the classification problem using regression? With linear regression, you fit a polynomial through data. Say like you fit a straight line through tumor size, tumor type. It is a sample set. Okay. So let's say above this is this particular thing. Okay, what you are telling that above malignant tumors get one. Okay, malignant means one, and non-malignant get the zero. The green line is our hypothesis h of x. Okay, it is h of x. To make a prediction, we may say that for any tumor size x, if h of x is greater than 0.5, it is a malignant. Okay, it looks like we would correctly predict every single training set sample. Now let's change a task bit. Like it's clear that all tumor large certain threshold are malignant. So let's add another sample with huge tumor size. So run the linear regression again. So what happens? It will continuously gives the wrong predictions. There may be a case, right? Like maybe it may be not a malignant, right? So these are the things that this classification. And classification, what happens is like I will tell you one thing, folks. Okay, there is one particular thing which I have explored this. Just a second, in the logistic part, there is a yeah, there is a one thing where it will. Yes, yes, yes. Just a minute. What it will do is it will, to solve the logistic 0 to 1. Okay, best fit line. Yeah, it will squash this particular thing. Okay, squashing due to the squashing. uh, we, uh, Due to the squashing, it will help us, like it will use a squashing technique, so that uh, so that it can find a slope and trying to find the particular slope basically. Okay, so mainly it is to minimize, like to reach the convergence for like local minimum. Okay, so to find the best fit line basically for the linear regression, they might ask like why it is so, like what are the certain things they can ask. So try to focus on that later. Okay, what is a decision tree now? Decision tree is one of the supervised learning algorithm that can be used in classification as well as the regression problems. Okay, so you can use for the classification also, and the regression also you can use. So this decision tree can be used for categorical and continuous. Okay, so decision works like a if then statement. The decision tree tries to solve a problem by using a tree representation, node and leaf. Okay, like try to understand the assumption in the decision tree. What happens initially, all training set is considered as root. Okay, feature values are preferred to be categorical. If continuous, then they are discretized. Okay, records are distributed recursively on the basis of attribute value. Which attributes are considered to be in root node or internal node is, it is by using a statistical approach. Okay, which particular feature we have to consider the root, which consider that has to be considered as leaf, or whatever the things is there, that like they will be asking like what is the entropy information gain and Guinea index and reducing the impurity. Okay, so further split is wanted or not, that will depend upon how much that particular feature is pure or impure. That can be determined by the entropy, and the Guinea index will be going to find it out. Okay, so let's get started with that. Like there are a different approaches to split the node and decision tree. There are a few algorithms to find an optimal split. One is an IDT ID3, and another one is what? ID3 iterative dichotomizer, and another one is CART algorithm, classification and regression tasks. Okay. For ID3 dichotomizer, this is a solution for entropy and information gain as a matrix to form a better decision tree. So what we do uh, entropy and um, like information gain, will do it as a matrix. Okay, entropy is a measure that characterizes the impurity of arbitrary collection of an examples. Entropy, how you will find it? Negative of probability of C categorized log p to the base 2 of that particular category. Okay, categorized data. Okay, so entropy varies from 0 to 1 and single class 1 if the class distribution is equal. Okay, so step to decide to attribute to split or not. So you will, what you do is you will compute the entropy of a data set for every attribute. You will compute that. And which entropy is higher, you can consider that. Calculate the entropy of all categorical values and take a average information entropy for the attribute and calculate the gain for current attribute. Pick the attribute with the highest information gain. repeat until we get the desired tree. Okay, so this is a thing we'll be going to do. Entropy and information we okay, so this is a thing we'll be going to do it. So classification regression tree. Classification and regression tree. In CART, we use a Gini index as a matrix. Gini index is used as a function to evaluate the split in the dataset. So steps to calculate the Gini for a split. So Gini for subnode using the sum of the square of probability of success and failure, P2 plus Q. Okay, so like split is required or not depends on that. Okay, so how to control the left height and pruning? You will control the leaf size. We can set the parameter as max depth, maximum depth, like limiting the stop for the splitting of the nodes, where the specified tree the depth has been reached. Okay, so during the building of initial decision tree, you will be thinking which particular trees to cut down. Okay, so that is only the pruning. Minimum split set, how many number of splits you wanted to carry out. Number of Okay, so minimum leaf size is like number of child node is lower than the minimum leaf size. So cleaning is due to the reduce of chances of mostly done to reduce the chances of overfitting the tree to the training data and reduce the overall complexity of the tree. Okay, there are two types of pruning. There is one pre-pruning and post-pruning. Pre-pruning is also early stopping criteria. As the name suggests, the criteria that set as a parameter values while building a model. So you will be going to use a early stopping criteria. That is nothing but pre-pruning. Whenever it is a early stopping criteria, you think that it is a pre-pruning. Post-pruning, the idea is like decision is groovely fully and observe the CP value, and we prune and cut the tree. CP is nothing but complexity parameter value as a parameter you can consider. Okay, so like this. Okay, how to handle a decision tree for numerical and categorical data. Okay, so decision tree can handle both categorical and numerical variables at the same time as a features. There is not any problem in doing that. Okay, so every split in the decision tree is based on future feature. If a feature is categorical, then split is done with the elements along to a particular class. If the feature is continuous, split is done with the higher than the threshold. At every split, the decision tree takes the best variable at the moment. This will done accordingly to due of the impurity measure. So impurity measure is nothing but like how much pure split it is. Okay, how many pure split is basically, let's suppose in your data set, let's say there are a number of cases of yes, 3 yes and 2 no. Okay, these are a nothing but impure split. That is a nothing but impure split. If it is case of 3 and 3 yes and 0 no, it is a pure split. Okay, so it is like that basically. So at every split, the best variable at the moment, this will be done according to the impurity measured with the split branches, and the fact that the variable used to do the split is categorical or continuous is relevant. Okay, so at last, the good approach is always convert your categorical to continuous using the label encoder or one hot encoding. Okay, so label encoder or one hot encoding will going to do it. So now next thing is consist of random forest algorithm. What is this random forest algorithm? Okay, random forest is an ensemble machine learning technique where use the bagging technique. It is also called as bagging technique, folks. Okay, so the best estimator in the random forest are the decision tree. In the random forest, it takes a decision trees basically. So random forest select the set of features that are used to decide the best split at each node of a decision tree. So this random forest creates subset created from the original data set. That is called as bootstrapping as well. Okay, so random subset which are created from the original data set. Okay, so at each node in the decision tree, only a random set of features are considered to decide the best fit split. Okay, so and decision tree model is fitted on each of the subsets. So final prediction is calculated by averaging the prediction of all the decision trees. Okay, to sum up the random forest, randomly selected data points features are built multiple trees. Okay, random forest is used for the feature importance selection, feature feature importance selection, and we will be using the feature importance, which is used to find the feature importance. Basically, some important parameters you can consider about like Gini, entropy, minimum number of splits, okay, minimum sample split. Okay, so these are the thing you can consider. Then you might ask like, what is this entropy now, right? What is an entropy in decision tree? So you can just find it out here. Okay, so you let's say, uh, what is a what is an entropy what is an entropy information gain and gain index in decision tree, right? So we'll just try to understand that part. Okay, what that is there. So you can think of like this. Okay, they have given the nice explanation here. So you can think of like this. Okay, I take a through a simple example. Okay, those who they have given written on one blog. So try to understand this. This thing you will be understanding by this particularly. Okay, so what is a decision tree? Root node and subnode or terminal safe nodes. Why do the trees overfit and how to stop this? Okay, so what does a decision tree do? They have given the written nice documentation here, so you can go through this blog article. So I will put into the comment down below, so you can just go through once. Okay, so nice documentation, folks. Like, they have given nice thing. Okay, so let's begin a real beginning with the core problem. For example, we are trying to classify whether the patient is diabetic or not basis on the various predicted variables such as fasting blood sugar, BMI, BP, etc. This is obvious a prediction problem for a new patient. Right. We have 1,000 patient records to help us develop the understanding for of which features are most useful in the predicting. Unlike other classification forms such as logistic regression, decision tree have somewhat a different way of functioning and identifying which what variables are important. Okay. So first thing to understand in the decision tree is that they split the predictor space. They target the variable in different subgroups which are relatively more homogeneous. Okay, for particular target variable. For example, if the target variable is binary with the categories 1 and 0, show by green and red dots in image below. Okay, so target is variable is green 1, red 0. Okay, so you will be going to split based upon the criteria of the two. So understanding the components of a decision tree, there is a root node, there is a node priority and decision nodes. Okay, like uh, the target variable such as diabetic or not, and its initial distribution. Okay, so target maybe. So first thing is we have to do, what is this root node? In the decision tree, what happens is there is a root node, and this is a node that begins with the splitting process by finding a variable that's best split the target variable. Okay, that splits the target variable. That in our case, target variable is diabetic or not diabetic. Okay, so second thing you have to consider is node purity. Node purity is nothing but, yeah, these decision nodes are typically impure. Okay, mixture of both classes, right? Like target variable 0, comma 1 and red dots in the as we see in the image. Okay, then it comes the decision nodes. There are some sequence or intermediate nodes where the target variable is again split by other variables. So leaf node is like, your splitting criteria is done at the the conclusion is came. So you can just look like this basically. Okay. Hypothesis or condition that makes a decision whether the condition holds or does not. Okay, this is the first level of decision tree. So decision trees offer tremendous flexibilities that we can use both numerical and categorical variables for splitting the target data. Okay, so important things that data science perspective are like flow of information through decision tree. How does decision tree selects? Okay, first the problem we have 15 data of a student data pass or fail. Okay, so we have a data. So flow of a decision tree is like this: working or not working. So, entropy and information variable selection criteria is like decision lies now variable like entropy, information, gain, and Gini index. These three terms will comes. Okay, entropy is a term that comes from a physics and means a measure of disorder. More specifically, we can define as it is scientific concept as well as the physical property that most commonly associated with state of disorder, randomness, or uncertainty. The term and concept are used diversified with the classical these are blah 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 they have told. Okay, so like entropy is measured by the formula like minus of summation of I equal to 1 to n pi log to the base 2. This is a thing. Okay, like probability of passing by total number of instances. Information gain is current minus entropy change. uh, Rather than using this folks, there is one another blog article you can think, yeah, this gigs for gigs, they have given nice actually, can think of you can look at it. Okay, so I will just if you want you can put in tell me so I can do it. Okay, so question number 9 is like what is a variance and bias trade-off. So in the prediction models, prediction error is composed of two different errors. There is one is bias and another one is a variance. Okay, whenever you are doing with the prediction model, there comes the two factors. One is a bias and another one is variance. It's important to understand the variance and bias trade-offs, which tells you to minimize the bias, and variance is in the prediction and avoids the overfitting and underfitting of the model. Okay, so bias is like it is a difference between the expected or average prediction of the model and corrected value which we are trying to predict. Imagine if we are trying to build more than one model by collecting the different data set. Later on, evaluating the prediction, we may end by different prediction of all the models. So bias is something where you will measure how far the model prediction from the correct prediction. Okay, it is measure how far the prediction of the model from the correct prediction. It also leads to high error in training and tested data. Variance is nothing but it is a we can build a model multiple times. So the variance is how much prediction is for a given point vary with the different realization of the model. Vary. That is nothing but variance. Bias is nothing but how it is maybe differed from the correct prediction. Differ. Model prediction, how far this model prediction from the correct prediction. How far it's nothing but bias. Okay, for example, so voting Republican, okay, 13 voting Democratic. Mm, it's simple, folks. Like, for an what are the ensemble methods? Ensemble methods is composed of two things. One is a bagging and another one is a boosting. Okay, back decision trees are more around for longer time and also known to suffer from bias and variance. Okay, you will have a large bias and with simple trees and large variance with complex trees. So ensemble methods which combine several decision trees to produce the better predictive performance basically. Okay, so main behind the ensemble method is to a group of the weak learners come together to form a strong learner. Okay, the two techniques to perform the ensemble trees basically. One is a bagging, another one is a boosting. So one is a bagging. We will be calling as bagging as a bootstrap aggregation, which is used when our goal is to reduce the variance of a decision tree. Here is the idea to create a several subsets that training samples choosing the randomly with a replacement. So now each collection of subset of data is used to train their decision tree. As a result, we end up with an ensemble of different models. So average of all prediction from the different trees are used for a one single decision tree. Okay, that is a bagging. Another one is a boosting, which is a like create a collection of predictors. In these techniques, the learners are learned sequentially with early learners, fitting the simple models to the data, then analyzing the data basically. Okay, so for errors, in other words, we fit consecutive trees random sample, and every step the goal is to solve for net error from the priority. When the hypothesis misclassifies the input if weight is increased, so that the next hypothesis is more likely to classify it correctly. So by combining the whole sort of and converts the weak learner into a better performing model. Okay, so different type of boosting algorithms is like data boost, xg boost, gradient boost. Whenever the word comes the boost, that is nothing but a boosting algorithm. Okay, this SPM we have already talked, folks. Okay, I don't wanted to repeat once again this particular thing. You can uh, think of naive Bayes classification, Gaussian naive Bayes. Okay, Bayes is Bayes theorem is like finding the probability of an event occurring of another event is that has already occurred. Okay, so these are the thing you can like new base is basically for like these are the new base is generally they don't ask basically. So now we'll get back to confusion matrix. Confusion matrix is a table that is defined that is oftenly to describe the performance of a classification model or classifier. Okay, so it also visualize the performance of an algorithm. All right, so this is a particular thing basically. Okay, though, so confusion matrix is a summary of prediction results on classification problem. Okay, the number of correct and incorrect predictions are summarized with count values and broken down by each class. Okay, so this is a key to confusion matrix. So it gives the insight not only the errors but also made by the classifier, but more importantly, the types of an errors that are being made. Okay, so like actual and predicted. Okay, class one, class two, and class one, class two. Actually, what it is they are predicting. So whenever that is 1 and 0, okay, so positive, okay, true positive and true negative, false negative and false positive. Okay, TPFN, FPTN. Okay, this is something like this. Class 1 is positive and class 2 is negative. Okay, so understand like that. Okay, so uh, let's say class 1 is 0. So 1 and 0. Yes, folks. Okay, so this is a particular thing, and P is positive, N is negative. Observation is not positive. For example, not an apple. True positive is nothing but observation is positive and predicted to be positive. Okay, like that. And there are something called as accuracy means classification rate. Accuracy is defined as uh, total positives plus total negative TP plus TN by TP TN FPFN. Okay, that will be accuracy. Misclassification rate. So there will be a specificity. Error rate means classification rate, sensitivity, F1 score. Okay, these are the things we can consider. F1 score is what? So F1 recall is defined as a ratio of total number of correct classified positive examples. Okay, so F1 score precision is a get the value of decision. We divide the total number of correct classified positive samples by the total number of predictive positive examples. Okay, precision is equal to TP by TP plus FP. Okay, so this is a thing. F1 score is like to measure. So if you are in like dilemma which one to choose, like precision or recall. So recall will what it will do, it helps the measurement that represents both of them. Like it will gives the correct statistics of precision, accuracy, and this recall will always be nearer to the smaller value. Like F measure is like 2 into recall into the precision divided by recall plus precision. This is one of the cross-validation technique, randomized search CV. Like it is performed to random search on the hyperparameter, like predict, probe, decision function, transform. These are the things we can consider. What is a grid search CV? Grid search is a process of performing hyperparameter tuning to determine the optimal values of given model. What is a Bayesian search CV? Bayesian search is in the contract is to like to the grid and random search keeps the tracks of past evaluation search. Okay, which they use probabilistic model mapping hyperparameter to a probability of a score on the objective function. Okay, so these are the cross validation technique, folks. Don't worry about it. Okay, these are the cross validation technique for the focus on more on basic stuffs. Okay, that's it about this day two video, folks. I hope you understood what are like I skipped the Bayesian kind of a stuffs, folks. Why? Because uh, if you want particular stuffs, why? Because if I explain that, it will take a lot of time. Okay, so okay, so try to understand. If you want to explanation on that, just comment down below, folks, so I can record a new video for that.